build up charge over time, and that's governed by the type of circuit that they're in. So if we draw our capacitor again and we hook it up to a circuit, there's our power supply, here's a resistor in our circuit. What will happen as the current starts to flow? Well, at first, the current will flow freely around the circuit. It's easy for the current to flow into this plate here and slowly build up a negative and a positive charge. And what we will see if we have a voltmeter across there is we will see, as time goes on, we will see the voltage start to grow. And it will approach, over time, it will approach the supply voltage, the voltage of the battery. So this is charging. And then, let's say we disconnect it. Let's say we open up something else in the circuit. It will discharge. And at first, it's going to be very, very, very easy for the charges to leave the capacitor's plates. So it's going to start with a high voltage and it's going to discharge that voltage. Okay, remembering voltage is potential difference. So this is discharging. So let's think about what happens to the current in the circuit as it's going. So at first, we've said that the voltage is 0. There's no voltage across it. But we've also said it's easy for the charges to move. And we know that if it's easy for the charges to move, they'll move quickly. And that is essentially what current is. So our current, while the thing is charging, will start big, but it will quickly get small. So over time, the current will start big and it will quickly get small because it's hard for the charges to get onto the capacitor now. It's hard for the charges to flow. Therefore, the current will get smaller and smaller. When it's discharging, the same thing happens. So the charging and discharging was opposite for voltage, but it's the same for current. A large current will flow at first because the charges are desperately trying to get off the plates, but then it will slow down because there's fewer and fewer charges that it's got left to move. So this is all well and good, but it's hard to see how you solve problems with it. And physicists have got around this by introducing something called the time constant. Now, the time constant is a quantity governed by the circuit that we've got, and the time constant is the resistance in the circuit times by the capacitance in the circuit. And you can see that if we change any one of these two, we can manipulate how long it takes to charge up. The time constant is time to charge 2/3 of way to the maximum. So it's the time taken to charge 2/3 of the way towards the supply voltage. And then another time constant, it will have got 2/3 of the remainder of the way. And then another time constant, 2/3 of the remainder of the way again. So it never quite reaches the supply voltage, but that doesn't matter. We can figure out the time constant and use that, manipulate that by setting up our circuit in a certain way to make sure that we can charge up our capacitor in the time that we want. Because next we're going to talk about applications and storage of energy.